Okay, so today's our topic is exploratory data analysis with F#. So I think the most people who are doing or in this domain like data analysis, mostly they are using Python, and there are some other programming languages also like R, and some people are using SAS tool. So these are very popular languages, but I think we haven't heard about F# so much. But talking about F#, it has endless possibilities. First, because it's a Microsoft, it's like provided by the Microsoft .NET Core, so it can be very much easily, like can be, like handshaken with C# or other Microsoft libraries basically. So it has a very rich library, and it is a statistically typed functional language. Like there are many statistical libraries, like it is very rich in statistical libraries, mathematical libraries, which we can leverage for the data science, data analysis. So our today's agenda is we will have a F# overview and some overview on EDA. So the people who are, like new to EDA or why EDA is done, what is exploratory data analysis, so we should know a little bit about that. Why F# could be better than Python. So there are many reasons like why F# can be used over Python. And there are pros and cons, of course. So Python is very widely used, and it has its like people have have their comfort zone with Python. But yes, but F# is also very like, it is like syntax wise it is easy, and it is not so much complicated, and we can use it, like widely in data science. So the libraries which we will use to showcase a machine learning model or regression model, that is Microsoft ML.NET. And I will talk a little bit about Fusion charts. So this is again a very, like comprehensive charting. We can do data visualization, and we can, like Fusion charts, we can actually, like incorporate with C#, Java, even Python. So most of the languages can be incorporated, like they can call Fusion charts. So it just comes in the JSON format or the XML format. I have used it in the past, in my past projects, and it is very effective. It gives great visualization, great interactive dashboards. We can do some good drill downs on these charts, and it is like, it looks great. So this is about Fusion charts. Okay, so going forward, I have given the link of the Fusion chart also. So this is an official link, and it contains all the documentation about Fusion charts. Okay, so going forward, like as already I think the moderator has spoken about me. So what is not spoken till now is that I am little bit interested, like in in handshaking of different technologies. Like I do lots of research, and I see that how, like different tools can talk to each other. So previously also I have done some handshaking with the RPA server and the .NET server, and other tools like C# with Python, and Python with Excel VBA, and again calling VBA like Python from VBA and VBA from Python. So I like to do, like, because nowadays if you see, like we work with lots of legacy tools and legacy applications. So it is like important, like irrespective of what is the language or technology used behind that, we should be able to, like talk with each other. So the tool should be, like easily compatible to talk to each other. They can send data, they can receive data. Those kind of things I am interested in. Basically, like I am a 0 to 1 kind of a person. So I take something and I, like fully developed it and I own it. I have a passion for coding, um, and in my free time, actually, I write code like in the pen and paper. So that is something I like to do. It is kind of, without coding, I cannot leave only, and I cannot sleep also. So I have also worked like for 16 years as a, like as a software developer. Then slowly, like moving forward, I have rose the ladder, and now I am leading also a team. And I have led the digital transformation projects for almost a decade. In like, and I have delivered like mostly in AI, ML, and data science kind of projects, and also RPA. So this is specifically regarding my career. Personally, I like to trek. I like to bike a lot in the off-road, and I like to solve puzzles. So this is about me. I am also like doing some research work in blockchain and smart cities. Okay, so going forward. So let's have a F-sharp overview first. Because I think most of us, I think it's a very, like the first time we must be or maybe hearing this term. So it is a functional language. It is not an object-oriented language. It's a functional language. And this is the official link of F-sharp. So this is a, like here you can get the documentation of the F-sharp, and it has a very rich community and the documentation is available. Though most of the projects are not very, like widely explored in this domain, but yes, but slowly, like the work has started and it is moving on. So I have written also, like my first book is on the like VBA, like automation in VBA. And now I am writing the second book on this. So it is on the machine learning and data science space with F-sharp. So I am little bit researching on this topic also. Like how it can be, like very easily used with the machine learning models and for the data analytical projects. So so if you see some integrated libraries on these are FS Lab, okay, then ML.NET. So again, it's a machine learning framework. Then there is SciSharp Stack. So it is again like data science and machine learning framework and the AI interface. So there are very like many other languages, libraries available. So going forward, if I talk about charting, so Xplot is very widely used with F-sharp programming. Plotly.net is there, which is again another awesome charting. Then some other packages like math.net. So it is a mathematical library which provides, like all the numerical, statistical calculations, probability model, etc. Then there is TensorFlow.net. I think the people who have worked in TensorFlow in Python, so it is like a .NET binding of that, the same library. It is a machine learning library again. Then there is TorchSharp. So it is a .NET binding for the PyTorch. And again, there is DeepSharp. So that is like a derivative calculation library. So it is very much rich. If you can see that it is very much rich in the mathematical and statistical libraries. Then there is mxnet.sharp and a lightweight linear algebra library, FSLG. So all these libraries I also haven't explored yet, but what is needed for data science and machine learning, some of the libraries I have explored. Okay. And the interoperability. So like why we use the F-sharp and, like what is the advantage? So F-sharp can be very common, like very, like commonly it can be like, as I said, that it can talk to us. So as I was like talking about that, I like the, like the things, and I like to research on the things which can easily, like interact or communicate with each other. So this is also called interoperability. So F-sharp can be very, like it can very easily handshaken with R. So R is another data science language, and it is very widely used in statistics and data analytics. Then F-sharp is can very, like very widely it can communicate with MATLAB. So MATLAB is another mathematical, like language, mathematical and statistical language. It is also one of my one of the most favorite languages. I have worked in MATLAB before, and I am doing also some work on this, like just, like to make F-sharp communicate with MATLAB. So this is again another, like great thing to do. Then F-sharp can communicate with Python. So F-sharp and Python can easily communicate. Then F-sharp can communicate with other languages like Mathematica and Wolfram. So this is like, like F-sharp can be easily, like it can, if you are programming in F-sharp, we can also, like build some, if other models are built in some other language, we can easily communicate or we can easily call those modules. So this is what it means. Okay, so going forward, let's understand what is EDA. So EDA is also known as Exploratory Data Analysis, as the name says, and let's see what it is. So basically, EDA is an approach to analyze data using visual techniques. Okay, it is part of feature engineering. So there are actually 3 steps called feature engineering, feature selection, and then we actually put the data to machine learning models. So it is a part of feature engineering process, and it holds 30 to 35% of the entire analytical process. So most of the time, like if you say a good number of time we spend in this part, where we need to analyze the data, we need to look into the data, we need to understand the data. So again, data analysis is the science of, like getting the information or the useful information from the raw data, or how we can make the data meaningful, right? So EDA is the first process to do it. Like we are acquiring the raw data and we are trying to make it a useful data for our training model. So that is what EDA is doing. Now EDA, like comprises of course, analyzing the raw data, but what does it mean? We need to analyze that what kind of data is there, whether it's a numerical data, whether it's a categorical data, or whether it's a ordinal data. So let me give you an example. Say we have a data where year is there. So year is definitely a numerical value, right? So if I say that to 2022, 2021, 2030, so a year column is there. But it is definitely not the data where we can, derive mean, median, and all these components, right? It is a data, it is a numerical value, but it is not actually a numerical data in that sense. Even if you see, like if you take an example of a ordinal data, like the rank, so it just tells the position, right? The rank is 1, 2, 3, 4, like that. It's like the value can be numerical, but it doesn't mean that the data is, you can derive the mean and median from it, and it is actually meaningful, right? Because it is just showing you the position of a person or position of a race, right? So that is how we need to understand the data. So every data, that it doesn't mean that if it is numerical in nature, it has to be a numerical data. We need to understand that what is the useful information we are getting from it. So if I say about cells and the numerical values are there, yes, it's a numerical data because we can derive mean, median, and we can do other analysis on that. Profit. Likewise, if it is a numerical data, we know that it is a numerical data. It is a numerical in character also, and yes, other statistical derivations also we can do. We can describe the data in that way, right? So definitely, like the data, if it is in numerical, that doesn't mean that it has to be numerical in that sense. So it can be a categorical data also. Sometimes the gender is given in the numerical values, like 0, 1. So if it is male, like 0 represents male and 1 represents female. So in that way, it is actually a categorical data, but it is just, like represented as a numerical value. Okay, then we do the missing value treatment. So definitely we see that if there is any null values in the rows or in the entire data set, if the values are missing, and how we can treat those values so that we can get a, like a good, we can train the data accurately. Then there are outliers. So sometimes it may happen that, like data falls actually, beyond what we called as interquartile range, basically. So what does it mean is that, let me give you like an example in the layman's term. So suppose, say we have a data where we have the salary of the developers. Now, say with 5 years of experience, right? Now 5 years of experience, and we are seeing the mean salary or the median salary, which is coming to be around, 90,000 or 1 lakh. Okay, so it is near about, like, the data is near about 90,000. The median value is 90,000. Let's say 90,000. Okay. Now, there can be some exceptional people whose data is actually, whose salary is very, very high. For whatever reason, maybe they are working in a very good company, or like they are working outside abroad. So whatever may be the reason, their salary is very high, and it is like, like 1 or 2 components, it can happen that 1 or 2 people, it can happen that the salary is beyond 2 lakhs maybe monthly. So that is definitely not not describe your data, right? Not your data set, correct? So it actually falls, like outside. So those the kind of data we, consider as outliers, because it is actually not not describing our median data or the mean data, right? It is actually like, if I take the salary of the employees, and with that I take the salary of the CTO. So definitely the CTO or the CIO salary will be very high, and it falls in the outlier category. So what will happen, like if we keep the outliers, definitely our mean or the average data will, will shift. So the mean data, if it is 90,000, then if the outlier is there, our average is going to increase, right? So it won't give us the good description of the data. So if I take the average of 10 people, then it might come that my average is coming as 1,50,000 or 1,60,000, right? Because 1 or 2 component is very much high. So it is actually not giving you a good description that how much a normal developer get, right? So there we need to treat the outliers. And also we need to visualize data, like how the data is looking. So sometimes it happens is that we need to do some like correlation. So we need to see that how the variables are interrelated to each other. We need to plot the scatter plot and all, and we need to do some, like ANOVA analysis. Then we need to do some hypothesis testing. So all these things we need to do on the data to understand like how the data and to analyze on the data further. So this is actually the part of, like the EDA, and these are the things which I talked about now. So this is what we do generally in EDA. Along with that, we do clean the data. So basically we treat the missing values. We actually, like delete the outliers. If there is any outlier data, we treat the outliers. Then if we can bean some data, suppose like we can group some data. Suppose we can put like, if we are, like doing like building a recommendation engine on the Netflix programs. So we can see that 0 to 5 years age, or not zero basically. So let's say that 5 to 10 years age, this is children, so child's program or the children program. So 0 to 10, sorry, 5 to 10, we can group together, right? Then 10 to maybe 17, that we can define as this is a teens program. So 10 to 15, again, we can group. So based on the age group, we can group data. So again, we can do some grouping on that, right? So in this way, we can, like do the entire analysis, and we can present the data in a format which is very clean and which is having some, like meaningful information. So generally, most of the times, if you do the EDA, like the entire exploratory data analysis, it happens so that maximum times it happens that mostly your analysis, like you can, like recommend something on the data, like just seeing the visualization and the data, how it is coming and all. You can recommend something, you can have an understanding of the data, you can recommend something on the data. So this part is very important, and this is the first step, and this is a very important step. Okay. Now, as I said that, so these are the some of the things like handling missing values, where we need to replace the values with mean, median, or mode. Now, uh, definitely see the missing values won't be replaced with mean all the time. If the data is symmetric, so basically we are seeing that how the data is falling in the normal distribution. And again, we will, like understand the skewness of the data. So in the following slide, I will little bit give a brief, like overview what is skewness, and where the, like data is treated with the mean or the median or the mode. Then how the, the outliers are treated, how we understand the outliers basically. So we can plot a box plot, and we can understand whether the data is falling in the outlier zone. Okay. Now, and the scaling down the data. So all these things we do in the EDA. So basically, it is like you are taking the raw data, you are doing the EDA or the feature engineering, and you are producing the data to the machine learning model. So that is you're feeding to the machine learning model, so that we get a good fit, or like get a good recommendations. Going forward, so let's little bit understand this. Like as I talked about, like we do to treat the missing values and all. So I generally, like show this thing because, like to have a understanding that how data, like sometimes how we treat the missing values. So see, like this is the normal distribution. So we already know, or we all know, like it's also called as a bell curve or the Gaussian distribution. And most of the time, like if you see here, like 68.2% of the data lies between mu plus minus a standard deviation. So what is mu? Mu is my mean point, mean, and plus minus standard deviation. So 95.4% of the data which stands between the mu plus minus 2 standard deviation, and 99.7% data which lies between mu plus minus 3 standard deviation. Okay, so this is how you can see an example also, like this is average mark, and this is very low and low marks, and this is high and very high marks. So this is how, like if you take random data in a very large sample, so somehow it will have a bell curve, or it will fall under the normal distribution. Now what happens is that every time the data is not symmetric, that means the right side data or the right side distribution is not always same as the left side distribution. So it can be slightly, like left skewed or right skewed. So what is mean by left skewed? Left skewed means when the data, the left side tail is bigger, longer, it can be referred as a left skewed data. So, and the when the right side tail is longer, or the if as you can see in the figure, it is self-explanatory. It is called the right skewed data. Now, that means the distribution is not symmetric, basically. It is not symmetric. It is not symmetric along the mean. Okay. So now from the definition itself, we understood, like from the diagram itself, we understood what does skewness means. So skewness is another important aspect of statistics. It can be called as, the measure of the symmetricity of the data, of the distribution. Okay, so if you see here, the data is left skewed. That means the left tail is bigger. Now, salary, okay, right, salary, where it falls, like which side, like it is left skewed or right skewed. It can be example of a left skewed data or right skewed. Right skewed, right. So basically, like if you see the middle value or the median, so most of the data will fall in the near the median. But maybe some people, like few people will be there whose salary will be very high. In that way, it will be rightly skewed. Yes. And any example for the left skewed data? Asian or working population. Coronavirus test. Okay. Another example can be like your, what to say, the lifeline, basically. So most of the people will have average of, like 60 to 70 years they will live, but very few cases will be there where people have a early death. So in that way also it can be left skewed. Okay. So these are some of the examples. So there we don't actually generally, like treat the missing values with the mean. It is not a good idea. So then we treat the missing values as with the median. Okay, some cases can be there, like where we have categorical data. Mostly categorical data are treated with, like the missing values are treated with the mode, but all the cases won't be same. So let me just give you an example, like if a profession is given, like for a, for a credit rating company, the profession is given, and the profession is given as doctor, nurse, engineers, and there are different professions, right? Students, housewives. So likewise, the profession is given. And this is basically a categorical data. So you can just see the profession of the people. And it is a category, right? So like there will be a category of doctors, category of nurse, like that. But see, if there is some missing values in this column, or in this particular column, there is some missing values that the profession is not mentioned, then can we treat with the highest number of profession which is offering? So mode is basically the highest number of, like the highest, the maximum value of, like any data set, correct? So if in that data set, particular data set, my maximum data set is, maximum value is doctor. So doctor has offered like most of the times. But still, I cannot treat all the missing values with doctors. It won't be, like a great idea to treat all the missing values with doctors. So we need to see like what percentage of missing value is there in the entire data set for those kind of things where it is very difficult to treat with something, treat with some value, then we can drop those missing values also. So that is also a good thing. Like if the data set is very large, and it is not a very considerable, like amount of data is there which is missing, then we can drop those data. Okay. So okay, so this is and again another important aspect, like how we treat the outliers. So these are actually very, very basic things. I am not going into much details of the exploratory data analysis. Today our topic is F-sharp, but I am just little bit giving, the brief on this thing. To understand like what we do actually in exploratory data analysis. So we treat the outliers also. So as I said that outliers, like can, like make your data actually like the data definition wrong, basically. So if you are defining your average salary to be 90,000 or 1 lakh, your outliers can make it 2 lakh. So and even it can be low also, like very low. So it doesn't give you, like the average description of the data. So this is a very good, like a very good plot that is called box plot. So it is like with box plot, we can understand whether how many outlier data is there and how we can treat the data. So basically anything, like which falls beyond in the left side, Q1 minus 1.5 into IQR. So if you see this Q1, Q3 minus Q1 is our interquartile range. Okay. And the left pane's formula is Q1 minus 1.5 into IQR. So anything falls beyond that is our, like we can drop these values. And again, anything falls beyond the right fence, it is Q3 plus 1.5 into IQR, we can drop these values. So we generally plot the box plot to see whether our data is any outlier is there in our data set. Okay, so then we can treat those outliers. Okay, so this is very much about exploratory data analysis. So what we do is basically we clean data. We analyze the data, like what are the numerical columns, what are our categorical values, and then if there is any missing values, then how we can treat those missing values, like whether we have to treat it with mean, median, or mode, how we can treat those missing values, or we can just drop those values. Then we can we can check some outliers. If there are some any outliers, then how we can treat those outliers. So this is also one important aspect. Then we can do some grouping of the data, like we can actually group the same set of data, or based on the age or based on other parameters like the salary range, we can group the data. Or let's suppose annual income, we can group that whether it is middle class or the upper class, upper middle class. So like that we can group the data. So that is also important thing. And basically we try to analyze like how the data is behaving, what is the description of the data, and basically cleaning of the data part. So this is actually what we do in EDA. Okay, so once this is done, then we are putting or feeding the data into our machine learning models to train the model. So this is what actually we do in the data analysis project. Now going forward, okay, so this is another important thing, that why I have chosen F sharp. Why not, like Python is doing great, R is doing great, but why F sharp? Okay, so if you see the popular languages, and this is the data taken for 2018, right? So popular language, it is not only for data analysis, but for other, like for the web applications and all also. So JavaScript is a widely used language, and then Python is there. So these two are very much commonly used language. I think now if we take this data, it will be Python. So Python is very widely used in everything. Okay, then C sharp is there. But what is the catch over here is, if you see this thing, then you will be understanding that what is the energy consumption here. Just let me know if this is visible fully. So if you see here that, like, if you see now, see the energy consumed by each of these languages, it is given. So if you see Ruby, it is 69.91, Python, it is 75.88, in Perl, it is 79.58. So these three are in the maximum or the red zone. So now when we are talking about sustainable development or sustainable architecture, then green machine learning concepts, because like as the resolution of UN to 2030 is also like we need to reduce our carbon emission. So then this architecture going with these languages won't be definitely good. I am not telling that F sharp is a very, like, it has a great energy consumption, no, but still it is better, like what we are seeing in Python, like 75.88. On that, if you go as to see F sharp or C sharp, because both are like the .NET, both are the components of .NET architecture or .NET core. So we can use anything. So C sharp and F sharp both can interact also with each other, and we can actually change the code also. Like we can translate the C sharp code to F sharp and F sharp code to C sharp. Only thing is that C sharp is an object-oriented programming language, but it is not that it doesn't support functional language. It can be written in the functional way also, or in the hybrid way also. And F sharp is fully functional language. It's a pure functional language. So if you see, like, compare these two energy consumption, like 75.88 if I take Python, and if I take F sharp or C sharp, it is far less, like 4.13 and 3.14. So this is one of the aspects where we are going for the sustainability and sustainable architecture, and we are going also for the serverless computation. Then green machine learning. Then these things like this, like choice of our language, it plays a very important role, like how we are building our model or building our architecture. So here it comes into play, like why in the flow, like, or in the coming time, why these languages will be very popular. Okay, so it is just a like we can just like plug and play for now to just understand and learn the language. But I think it is a very important aspect why we will choose this language over this language, right? So it is a important thing. Now, if you see, like for F sharp and Python, I will show in the code also. If you just load a big data set, like even for a very small data set which I am loading, I can see a significant time difference. So F# is loading that in no time, and Python takes some time. So, and the time is very much like you can understand that it is a like great, great difference is there. So, so there also we can see that F# is much faster than Python in terms of, like dealing with the big data. And also like while dealing with the big data, also the energy consumption in Python is more than in F#. And the difference we are seeing here. Okay, so going forward. Okay, so let me just show you some of the code and what I have done in the F#. I didn't get much time because one of my project delivery is also going, but I will post this code, like completing this full thing, and I will post this in the my GitHub channel. So then you can utilize those codes. So if you see here, like a data set is there, like I have actually downloaded two data sets. So this is a very, like this, you can use the kaggle.com. I think those people who are studying data analysis or doing work in data analysis, this is a very good site to download any data set. So I generally do the download the practice data set from here. You can get any kind of data set, the small, big, medium, so you can practice. So this is a very good site, and even like sample coding is also given, like how EDA is done, and different projects are also there. So you can go and explore this site a little. Then I also downloaded two datasets from here. So one is basically very small datasets though. It is not very big one. So one is the IMDb rating. So this is one dataset that is CSV file. Okay, so if you see, it is only 428 KB. And another is temperature change. Again, it is a very small one, so 439 KB. And these two are like for the practice purpose, it is okay. So if I show you here, like how the the time is taking. So this is a Python code basically. I am not doing anything on this. I am just loading the data. Okay, just loading the data on this. So if I just run this code, if you see, the time taken is 0.0339 seconds. This is the time taken. Okay, so it is here, like I have printed the time, the elapsed time. Okay, so 0.0339 seconds. Now, if I go and run in the F#, it is taking some time to install this F# data, actually the package. Okay, then here I'm actually loading this file. So you can see the difference actually. So it is 0.068 where it is 0.033. I will run it again, once again. F# takes some time to, just to, to install the package. So here you can see the difference basically. So it is the first time when I ran, it is just taking like little bit extra time, just to, to refer the package and all. So if you see the difference, it is a huge difference. So even it is a very small data set, but still Python is taking some considerable amount of time. So I have tested this with a very large data also, and I have taken this time difference is huge. Like F# takes very less time if everything is installed in the system and you are just loading the data. It is just loading the CSV file only. So if you see here, the time difference is tremendous. Like where it is 0.0010 and the Python Python is taking 0.035. So if you just multiply, I think it is coming like a good percentage. So it is a good multiplier. So here actually you can see that where like the resource is taking. So Python, that is why it is said that it is in the red zone, like Python is taking much resources. Again, if I run this code, you can see the same difference. So no matter how many times I run this, it is like it will be coming same, like little bit near here and there, but it will be coming same. Because once the data is loaded, maybe next time it is little bit low. But F# actually takes no time basically. It is run actually 0.00134 again. So 0.0216 now here you can actually, like make the difference of it. So this is the, like the time taken in the, like loading a file, and it is like a small file only. It is not a very big file, but still, like the time taken is, like much more. So this is here, like it is regarding sustainable architecture also. Like when we are dealing with the large data, I think we need to, like choose the language in such a way that it is sustainable in the long run. So again, this is here, and let me just show you some of the, like sample F# code, basically. So I was just little bit, like plugging and playing with it. Okay, so if you see, like I want to show this because of the syntax. So if you see, the syntax is very, like it is like Python only. It is very easy. Like even a child can understand this syntax. If you see, like add x and y and x plus y and add 2 and 3. So you are just passing these 2 and 3 to this function. So late is like you're declaring the function or the variable. So if you see here, the value is coming as 5. So it is a very like plain syntax. I'm not telling that it is a very complex programming, but I'm just showing the syntax part of it. So syntax anybody can understand. Now let's see how to build a list. Like if you take a like build a list of 1 to 5. Okay, the numbers. So you are just defining it like this. So 1 till 5. So you are just putting 2 dots. That means it is taking from 1, everything between 1 to 5. Okay. Now, if you want to append another item 6, so you can append like this. So this is actually giving you, like I have run the code also, it is giving you the, first it is like giving you 1 to 5, and then it is, like appending the last parameter, that is 6, right? So it is a syntax wise, it is very easy. So anybody can understand this. Okay. Then another important thing in F#, like this is a very good thing and I like it very much, is piping. So anything you want to do, you can put that in the sequence. So how I will explain. So if I tell you like, just let's take this, okay? So let's understand this. So here actually I have taken some names. So I have taken a list of names. So I have put Wheel, Jack, Jill, Humpty in the names list. Okay, so here I have taken a names list, and then I have written an address where I am prefixing with it hello. So it can be anything. Here I am sending hello. So I am just calling this function address and I am sending this prefix string hello. And what this function is doing, it is basically putting whatever the base string I am sending, like the base string which is calling this function, with that it is just adding the prefix string. So that is what it is doing. So if I say hello and my base string is containing Munmun, so it will give me hello Munmun. So this is what it is, it will give me the output. Okay. So if you see here, the names list is like I have printed names here. So the names is giving me Wheel, Jack, Zeal, and Humpty. And still now I haven't called this function. So let's call this function. Now this is a very good operator in F#, where you can actually, like sequence your operations. So suppose you want to do a sorting. You want to calculate you want to calculate some values based on the grouping. Then you want to, like treat some missing values. Everything you can put in just one line, like one line of code. Not exactly one line, but you can just put in the sequence and everything will be done at once on that list. So that is a very, like effective thing in the F#. So if I say now I have taken again the names. So names is again my defined list. Okay. So this will be actually getting mapped with this prefix with hello. So I am calling this function, and this function is actually sending, like calling this address function and sending the hello. Okay, so this will be my base string. So whatever string will be coming in this list, and it will get mapped with this prefix with hello. So it will give me hello Will, hello Humpty, like that. So if you see, it is just a 2 lines of code, and it is doing the, like we can tell, like it is a little bit, like similar to list comprehension in Python. But if you see that it is a very simple coding. So I am just actually, like sending the list of these names, and I am prefixing with it hello. And it is just, like just giving me the hello Will, hello Jack, and hello Jill, hello, like whatever you want to do with that name. Okay. Now going forward, so I have taken another function. Okay, so I have just defined another function called talk. Okay, and I am just passing a value s, and with s I am appending what's up. So I am just, like manipulating little bit string, and I haven't called this function yet. So what I am doing is again the same thing. I am taking my base list, that is my names, and I am first putting the prefix with hello. So I am just putting the prefix, like I am calling that function, the previous one, prefix with hello. And then I am like calling this function talk, and I am sorting it also, like sorting on the based on the names. So if you see, if you understand this, everything I am doing in the pipeline operator. So whatever, like you see the possibility of this. So if you have a data set and you need to do certain operations one by one, one by one, one by one. So basically my sequence dot map talk. So talk I am calling after I am calling prefix with hello. So once this operation is performed and my list I have got, like it has retained me the list with hello Munmun or hello whatever, hello Will or hello Jack. Then actually on that it is doing this operation talk. Okay. So once I'm doing the operation of talk, so talk is done, then it is returning me the list and then it is doing the sorting on the names. So you can understand that how effective it is and what kind of endless possibilities it can have when you will do the data analysis. Like when you just, like do the processing on the data set and like what you need to do one by one, you can just do it, like use the piping operators and you can just do it. Okay. So if you just see the function call and I have run it also. So it is like hello Humpty, what's up? That means what? I am sending Humpty and I have, first of all, I haven't sent in this order, right? I have sent Will first, right? So I have sent Will. Will has come with hello Will. Then the talk operation has happened. So hello Will has become hello Will, what's up? And hello, after that, the sorting has happened on the names. So then everything has got sorted according to the alphabet. Okay, so this is also another good thing in F#. So this can be leveraged greatly, and I am saying there is possibilities in this function. Okay, so this is again like a very good thing to do. Now I have combined these two functions. So again, this is another very simple syntax. Okay, so these things I liked actually, and that's why I'm showcasing here in this session. So again, this is a very important syntax. If you see, I have mixed these two functions and the syntax is very plain. Okay. So what I am doing, I'm first I will call prefix with hello and then I will talk. Okay. So prefix with hello and then I will talk. And then if you have any other function, you can just, like put this operator and you can put everything in a single function. So it is a big hello. Okay. So I have defined a big hello and where I have joined specifically these two functions, prefix with hello and talk. Right. So that means prefix with hello will be first operation and then it will, the talk will occur and then I will get my values. Okay. So now what I am doing, instead of calling my prefix with hello and talk separately, I am calling big hello. So big hello is what? Big hello is basically, it is sync with first prefix with hello and then talk. Right. So if we have some list of operations and we have already written the functions of it, like take the group of it, treat the missing values, take the mean, take the average, take the median, whatever we want to do the operations on the EDA, we can just, like write the separate functions and we can just put in the synchronization so that it will just occur one by one. And one function is called, the value is occurred, the value is returned, and then on that value, the second function is called. So if you see this, it is a weak possibility here. So the lines of code are actually decreasing. If you see, the lines of code are decreasing and it is very simple actually. I can understand, I think anybody can understand. If I am understanding, anyone can understand. So if you are again sending this names list and you are calling big hello. So big hello means your prefix with hello plus your talk and then you are sorting it. Okay. So if you see here, this is the result which you are getting. Okay, so it is the same result basically. Only thing is that I have taken everything, all the low order functions in a high order function, and I am creating an order of it. Like I need to do first this, and then maybe some other functions also I can put in the order. Okay, so this is something which is very, like effective. I feel it is very effective for basically these kind of things, like for EDA and all, where we need to do number of operations on the data. So we can just take the data set and we can do these operations. Okay. So do we have time? Okay, we have 5 minutes. I will want to show something. So if you see, so these are some of the, like I have taken this data and I have do certain operations here. So if you see, like I have put the like CSV headers. So if I run this code, so it will give me all the data headers basically. So if you see here, so these are my headers. Postal link, series, title, release year, certificate, runtime. So I can see basically my column header. So what we do in data analysis, okay, I couldn't complete this file, but I will put this in my, like I will complete the entire EDA and I will put in my GitHub channel. Then I will share the link. So if you see again, like what is my column index of this particular column, IMDb rating. So this is a try get column index. So this syntax, if you see, it is very like, like very minimal syntax, which like Python only. I am not telling that Python is also having very complex syntax, but it is also very easy to understand. Like it is not, like very difficult to think to grasp basically. Now again, like first row. So I am getting the first row. What I am doing is that I have taken these rows and on that I have put a pipeline operator and sequence.head. So it will give me the first row. So if I just run it, it is just giving me the first row, the social redemption 1994 A 142 minutes. So every details are coming. Okay. Then going forward, like if I am doing like I want to see the rows, like how many rows or what is there. So if you see, all the rows are coming. So basically, if you see here, all the rows are coming here. Okay. So if you see, there is like whatever it can hold, then it is more. Okay. So likewise, it is coming. Okay. Now see, if I have done some pipeline operations over here, basically. So if you see here, I have taken the rows and then on that I have mapped it like I have grouped by actually with the row dot item 5. What is in the item 5? Okay. So let me check. So this is basically like giving me the header, like the column index basically. So if it is 0, 1, 2, 3, 4, 5, I think genre. I think genre I have put. Let me check. Yes, so this is basically, like grouping by the genre. So drama, so for drama, all these, like parameters are coming, all these rows are coming, okay? So I have just put in the, like group by the genre, and then I have done the list dot head. Head means it is only returning me the single data set of it. So I have group by. So group by means actually, if I just delete this or just comment out this, then it will give me all the genres, basically. So here, if you see, it is giving me the data of grouping by all the genres. Okay. So this is drama, then crime drama, then action crime drama. So all these genres it is giving me. Action adventure drama. So whatever movies are there in these genres, this is giving me. Okay. So likewise, we can do, like some EDA on this. And the syntax is very easy actually. The syntax is not difficult. Uh, I don't know whether I have done something else also because I couldn't get time, but I will complete these and put that in my channel. So here also I have, taken, like for the horror genre, I have taken the list. Like I want to see some movies in the horror genre. Okay. So it is giving me the list. So likewise, I have done certain analysis on this, on the data. And I just played on the data, nothing else. So it is just giving me, like the data on the horror movie. So if you see horror, then again horror. So all these things you can do, like you can like little bit plug and play on the data. Okay, another data set also I have taken. So that also I had started long back, but I couldn't finish it. So this is actually, I try to do some charting and all. I will complete it and again I will put it in my channel. So I will share the link with you all. So this is the climate data basically. Again, I have, like done some coding on the, like just analyzing the climate change in the different countries. So this is the data. Let me just install these packages or just import these packages basically. Okay, so till we are doing this, till the packages are getting imported. So this is a one-time activity. Let me show you another code I have written today, actually. So this is basically, I have taken some, like some reference from the, like some person who has already worked in this before. So basically they have taken what the salary data, like on the years of experience, based on that, there is some salary data. And he has recommended, like based on this train data, he has recommended putting some regression model that what is your, like what can be your prediction on the 8 years experience, if you have, what can be your salary. So that is kind of a, like a prediction model or the regression model he has just programmed. So this is again like they have used a machine learning library, and it is like, it is very, like very rich. This ml.net library is widely used here. Just let me show you. So if you just go and search here, you will get this ML library. Okay. So it is very widely used. Another library is there. So all kinds of library you will get here in the Nougat package. So TensorFlow you will get. So these are all good libraries. You can see the TensorFlow library is there, tensorflow.net. Then you can install anything and use it, because all these libraries, great libraries, are used in machine learning. So then there is which one is there? I think Microsoft Spark. Let me just search. Yes. So this is again like .NET binding of the PySpark, or the like for dealing with a very big data. So this is again a very good machine learning library. Okay. So again, this is a very like a small code, and it is a very simple code only. Just I have taken a trained data, and based on that I have put a regression model, and I have done some predictions on my like salary. So salary for 8 years. So if I just run this program, let's see what I will get, since the time is very less. So again, this program is in F#. So it is written in F#, and it is very, like you can use the pipeline operators widely in F#, and it is very helpful actually. Okay, so it is giving me root mean square as minus, and R squared minus. So again, like it is a big minus. So I can just, like little bit I was plugging and playing with the machine learning models, basically, so training model. So I will just change the regression model and see like how my prediction can come. So basically the people who are working in machine learning, they know what is R square. It is actually the measure of goodness for fit. So it is good that if we get the value close to 1, then that means a good fit. Let me just change the model and see. So all these things I was trying actually. So still I am, like researching a lot on this F# machine learning libraries. So maybe I will put all these things, all my research work in my book. So let me just change this. So I was actually changing the regression model to Poisson regression, and then I think I got a good, like a good prediction. Yeah, so here if you see, it is coming almost 90%. I think it is a good match, like good fit kind of. The prediction is also coming like 43,000 or 4,30,000 something for the 8 years experience. So this is how I think you can do, like you can, like plug and play with the machine learning libraries also with the F#. And it is very rich actually, like Python only, it is very rich. The only positive thing I am seeing over Python is that there are basically two positive factors. It is fast also, and it is taking less resources. So that is, I think, two most, like critical factors which we can consider for learning this language. Okay. And then let me check whether this data is ready. Yeah, so basically, see, like I have done, like some, like against loading the CSV, I have just done some, like analysis on how the data is changing, or which country is having the highest, like temperature change or lowest temperature change over last 10 years, using some pipeline operations. So here, if you see, here I can have just use some pipeline operators like sort by descending, then take, like as I showed you, like it has very like good possibilities of, like to check like all these things, like to do like when you have to do, like number of processes, you can use pipeline operators. Okay, so likewise I have done here. One more thing I just want to tell over this. So we have, like because we are using F#, so here we are using F#. So we can add any kind of project here. So anybody who is working in .NET, they must be familiar with this, that if I want, I can add another web project in this, and I can actually build an end-to-end, like a good front-end data recommendation engine or something, like a full end-to-end project I can build on this. Like my backend libraries will be in the F#, and my front-end will be in the ASP.NET. I can build actually a very good, like there are endless possibilities, like end-to-end front-end language, front-end, fully front-end, like development I can do with my data analysis. So this is again another possibility. I am actually working on this. I will put this code also, like putting a, like full end-to-end front-end with the front-end full application, end-to-end application. Again, I want to show something, like on the Fusion chart. So this is actually greatly used in the, like with C#, with Python, with Java, and it is gives a very good interactive charting thing. So we have used it. This is an official library. I will just show you some code you can understand, like how you can implement these things. So if you see here, you can get the 2D graphs, and full documentation is there. The 2D graph is there, and how you can get this JSON and all. See the C# code, like what code you need to just implement in your C# file. You can just easily get this code. Okay, then the Java code of the same thing, like how you can build this library. And we have used it also before, like it is a great tool, like to give an interactive dashboard building. So any analysis you do on your F#, you just throw the code to the front end and you can use there the fusion charts, which can give you a good charting thing. So this is again a very good, like for front end you can use for C#, for Java, for Node.js, for Python. It is not, like language specific. Yes, just one more thing I want to show. I am done almost.
Excuse me, ma'am.
Yeah.
Ma'am, since we run out of the time, can you please answer the Q&A
Yes,
session?
yes,
And
yes,
we
yes.
can continue
Just
after.
yeah. Just one more thing I just want to show here. So there are some actually drill down maps where you can do, like this fusion chart only with the drill down mapping thing. So if you see here, this is like you can drill down these maps basically. So if I just click on this North America, see it is giving me a drill down interaction. Okay. So this fusion chart is greatly used there also. Okay. Yes. Now I will start the Q&A. Are there any other opportunities apart from Microsoft product? Okay. Is F# pre-compiled like MyPython? Yes, F# is pre-compiled. Are any other implementation opportunities apart from Microsoft products? There are endless opportunities, as I said, that you can communicate with R. You can have a good interaction with MATLAB. So MATLAB is a very good mathematical and statistical tool. So it has endless opportunities actually with the other tools as well. And especially if you're building like the API services, the microservices in C# or .NET, there also you have endless possibilities, like just to consume the services or just to, like build your own API services or build your own library. So you can do anything with this thing. Why the programming? Because it is in Microsoft .NET Core. So you can actually have endless possibilities over there. Why the programming language is named as F#? I am not sure about it. I can check on this. Definitely, it's a good question for me because I haven't checked this. Why it is F#? Okay. But the time required to test in different languages, is there any data regarding that? I have tested with Python, and Python's time is more than F#, and it is a considerable big time. For the big data, it is more. So yes, for the Python, I have tested. For other languages, I can still explore. Why the energy consumption parameter is said to be? What is the energy consumption parameter said to be? Okay, so basically it is a electrical consumption, CPU consumption, so your resource consumption basically. So there you have the, like energy consumption more in Python. Also, if you see the server, like how much energy, like how much carbon is getting emitted in the server rooms and all for the consumption, that is considerable in these languages which are in the red zone, like Python, Ruby, what we have seen today. How is compilation done in F# and Python? Can we compare on that? See, compilation for the F# is basically the .NET library, the .NET compilation basically, the compilation engine which we use it in .NET. This is a common language runtime. Okay, Python is basically the interactive language, right? So there are some syntaxes error which you are getting in the compile time, but it is like a duck typing language. So basically, we don't have to, like declare the variables and all. And it's the same for F# also. Okay. What are the similarities between F# and C#? So C# and F# is similar. Like there you can, both are in .NET Core, both like the compilation engines and everything is same. At the end of the process, it is just that like converted in the same binary code where you can like just communicate with each other. Only thing is that C# is an object-oriented programming language, so it supports object-oriented programming, whereas F# is a functional language. But it is not like that F# doesn't support OOPS or C# doesn't support functional language. We can use it in a, like some way or the other, but it is not exactly a functional language, C#. And F# is not an object-oriented language. Okay. Can you please suggest a book based for the YouTube channel for the PySpark? There are many actually in the YouTube videos and all. Some documentation is also there for PySpark, official documentation. I can suggest, I will check and suggest on the same. What is the unit of energy consumption? Again, I said you that it is a, like the average energy consumption in terms of the electricity and the like the CPU resources. So the units is not given. I will check with the units, like what is the unit exactly they are telling on. But I think they have given it is in the percentage. Like this is the percentage where they are falling in the red zone. Okay. So this is all. I think it is like like you got some insight from this. I am also researching a lot on this topic, and I'm trying to build an end-to-end application also for a recommendation engine. So once I will be done, I will be sharing that with in my GitHub channel. That's all from my side, guys. Have a great weekend.